Your book just loves these, so you better learn how to deal with them. They throw them in every place. Here we have x minus 4 as the denominator, and here we have 4 minus x as the denominator. They're not exactly the same. Now, I'm pretty certain what your book actually has you do is take one of them and factor a negative out. So, for example, if I factor a negative out of this denominator, I'm going to be left with positive x and negative 4. Everybody changes signs. Now, the way I want to have you do it actually is a little different than that. I'm going to multiply the numerator and denominator by negative 1. I'm going to wind up with an equivalent fraction. I get negative x, and I get positive x and negative 4. And now I have the same denominator. So the LCD now is x minus 4. Let's try another one of those. Okay, so same situation. I have same variables but opposite signs, and make sure every one of them has opposite sign. So what I'm going to do is I'm going to multiply the numerator and denominator of this expression by negative 1. Be very careful. So what do I wind up with? I wind up with negative x minus 1 over positive x, negative 3. Make certain when you have more than one term that you totally distribute the negative. And really, what are we doing? We're changing all the signs of every term in the numerator. Now my LCD, when we compare this expression with this expression, is just x minus 3. Okay, so to form equivalent expressions, we want to factor all denominators only, build our LCD using all factors of all denominators the most times that they occur as a factor of any denominator. And now we want to multiply the numerator and the denominator of each expression by all factors missing from the LCD in that expression. That was a lot to write, and I didn't want too many words. Let's look at an example. So we'd like to find the least common denominator of these two expressions, and we would like to rewrite them with that denominator. So the first one is 2 over 3y squared. The second is x over 6y. So the first thing we have to do is factor all denominators, but these denominators don't need to be factored. Next thing we need to do is build our LCD. And looking at the number part, well, we have 3 in the first expression, we have 6 in the second, and the smallest number that 3 and 6 divide evenly into is 6. Looking at the variable part, we have y to the second power in the first expression, so we know that has to be there. But we need to look at the second expression. That also contains y as a factor, but only 1, so the most it occurs is 2, so we only need 2. Okay, now, let me find, okay. I need to multiply by what is missing. Variable-wise, I'm not missing anything. However, I do need to multiply by 2 to get that 6. So I'm going to multiply the numerator and denominator by 2. And I wind up with 4 over 6y squared. In the second denominator, we have the 6. We have a factor of y, but we're missing the other factor of y. So I need to multiply the numerator and denominator by y. So I'm left with xy over 6y squared. Now my expressions have the same denominator. Now I could add them or subtract them. So we have these two expressions, and we are told to find the least common denominator and then rewrite these expressions with that denominator. So the first step, of course, is to factor all denominators, but these denominators can't be factored. And so the next step is to start building our LCD. Now, the numerical part, doing the traditional manner. So I'm looking for the smallest number that both 18 and 30 divide evenly into. Probably the two easiest ways would be to factor each down to prime numbers, and I do that if they're large, or take the larger of the two, which in this case is 30. Does 18 go into 30? No. Double it. Does 18 go into 60? No. Triple it. Does 18 go into 90? I have no idea. I need a calculator. So 90 and it does. So 90 is the numerical part of our LCD. So I'd rather deal with variables. Okay, the first variable is x. What's the most that occurs as a factor in any denominator? Twice, so we need two of them. Next factor is y. What's the most that occurs as a factor of any denominator? 3. And the last one is z, and we have z squared here, so we know we need at least 2. We have to see if it occurs more in any other denominator, but it does not, so z squared. So our LCD is 90, x squared, y cubed, z squared. Okay, now we have to rewrite these two expressions with that denominator. Well, the numerical part, we said, what was it, 18 times 5? So I know I'm going to have to multiply numerator and denominator by 5. Now, I have one factor of x here. I need two of them. What am I missing? I'm missing an x. I have one factor of y here. How many do I need? I need 3 of them. So I'm missing 2 factors of y. I have 2 factors of z here. How many do I need? 2 of them. So I don't need any more z's. So I'm not going to multiply by z. Okay, so what do we wind up with? Well, 5xy squared times 5 gives me 25xy squared. That's my first numerator. And of course, the denominator should be the LCD. Now let's take a look at the other one. Well, the numerical part, 30 goes into 93 times, so I'm going to need to multiply by 3. I have 2 factors of x here. How many do I need? I need 2. So I have all my factors of x. I have 3 factors of y here. I need 3 factors of y, so I don't need to multiply by any factors of y. And I have 1 factor of z here. How many do I need? I need 2. So I'm missing a factor of z. So we're going to multiply numerator and denominator by z. Let's multiply. We get 21z for the numerator. Okay, the dog is snoring and wagging his tail really hard. And now in the denominator, when we multiply by 3z, we get 90 x squared, y cubed, z squared, which is what we expect because we were trying to get the LCD, and that's what we got.